Now let's learn about transversals.
A transversal. A transversal is a line that intersects two or more coplanar lines. So I have a line here and a line here. My transversal cuts it right through the middle. All right, it cuts through both lines. All right, and as you can see, if you have two lines, you have an outside and exterior, and you have what's between the two lines, also known as the interior. Okay, and this line that cuts through them both is called the transversal. All right. All right, so again, if I were you, I would copy these down. Then let's talk about them. So you might want to pause it and copy those down. All right, so the first one now what we have here are very special relationships. And we need to know them by name so that we can talk about them. We're going to talk about them a lot this chapter. The first relationship we have are alternate interior angles. So interior, you know, it's going to be between the two lines, right? So if R is my transversal, it cuts between two lines. My interior is here, and then my exterior would be out here or out here, okay? So non-adjacent interior angles that lie on opposite sides of the transversal. So let's take a look here. Let's say I have two. That's on the interior, and it says opposite sides of the transversal, but inside. So opposite of this, and it also says non-adjacent. These are right next to each other. That's adjacent. So 2 and 6 are alternate interior angles. What's another set of alternate interior angles? 7, opposite 7, but not adjacent would be 3. So 7 and angle 3 would also be alternate interior angles. Okay? All right. Next one is same side interior angles. Same side interior angles. These are interior angles that lie on the same side of the transversal. So down here, 2 is on the same side as 3. Here again, here's our transversal. 2 and 3 are on the same side of that transversal. Don't get confused and think N or M is our transversal. R is our transversal because it cuts through two other lines. All right? So 2 and 3 are same side interior angles. So are 7 and 6. All right? Okay? Corresponding angles. Corresponding angles lie on the same side of the transversal and in corresponding positions. This is kind of tricky. All right, so let's take one here. All right. So you can see this is a group and this is a group of angles, right? This group is formed by the transversal on M and this is the transversal on N. So 1 would be in the upper left position here. What is in the same corresponding spot over here? 3. So 1 and 3 are corresponding because they're both in the upper left-hand position. How many corresponding angle pairs do we have? We have a bunch. 2 upper right because it corresponds to 4 upper right. 8 lower left, 6 lower left. So 8 and 6 are corresponding. And then last but not least, 7 and 5. 7 and 5 are both in the lower right, so they'd be corresponding. Okay? All right. Let's look at the last one. Alternate exterior angles, non-adjacent, so they can't be next to each other. Exterior angles that lie on opposite sides. So these are all exterior, so they got to be on the outside. So 4, 5, 1, and 8, those are the ones we're talking about. Let's look at number 1. If one's on the top side, it has to be on the opposite side, so the opposite side would be 5 because it cannot be adjacent. Remember, adjacent's right next to it. So 1 and 5 would be alternate exterior angles. 4 and 8 would be alternate exterior angles. All right? So let's go back and let's just label a few of these. So angle 4 and angle 8, those would be alternate. That'd be an example. Corresponding, let's say angle 1 is in the same position as angle 3. So those are corresponding. Same side interior, 7 is on the inside and it's on the same side of the transversal as 6. So that's an example for 7 and for same side. And then alternate interior. So let's say 2 and opposite side, 6. So angle 2 and angle 6. All right? That's a lot of them, I know.